Hello, students. These are the Bodhee Prep topic tests. These tests are designed to help you prepare yourself for a timed test. So once you've gone through basic concepts of a topic, you can refer to these topic tests and give these topic tests. Once you've given the test, refer to the video. In this video, will give you a perspective of how you can or what could have been a good attempt, the kind of questions there were, level of difficulty, etc. Also, if you like the test and the videos, there are more than 200 such topic tests available on the Bodhee Prep Android app. The link for the app is in the description of the video. So download that app and make use of these tests. This video is about the topic time, speed, distance, the first test on the app about on the topic TSD. Overall analysis, the test was a moderate level of difficulty test, and any attempt of about net 6 questions correct would be a good attempt, or 95 odd percentile plus. The time taken for this test would be about 20 to 23 minutes to attempt the entire test. There were some questions where there is a bit of calculation, and therefore on the higher side of or more than 20 minutes, as I'm saying, is a decent attempt time. If we look at the questions, question number 1, two ants A and B start from point P on a circle at the same time, with A moving clockwise on a circle A moving clockwise, start from point P, B moving anti-clockwise. They meet for the first time at 10 a.m. When A has covered 60% of the track. So they meet somewhere here. A has covered 60% of the track, therefore B has covered 40% of the track. And this happens at 10 a.m. If A returns to P at 10:12, now from this point on, then B returns to P. From this point on, A takes 12 minutes to reach P. So we can say that A covers 40% of the track in 12 minutes. From 10 to 20, 10, 12, it is covering the remaining track. And therefore, half of this 20% of the track, A will cover in half of 12, that is 6 minutes. And therefore, 3 times of this, 60% of the track, A will cover in 6 3s are 18 minutes. Now, before meeting, A had covered 60% of the track. Therefore, A would have started here at 18 minutes before 10 or 9:42 a.m. That is the time when A and B started moving around the track. Now, if we look at B, from 9:42 to 10 o'clock, that is in 18 minutes, B has covered this part, that is 40% of the track. 40% of track before meeting, that is the part B covers 40% of track in 18 minutes, the time in which A covers 60%, which means we have to now find B has to cover 60% of the track. So if we multiply this by 1.5 into 1.5, so 40 into 1.5, 60% of the track, that is the remaining track, B will cover in 18 into 1.5, which is 27 minutes. So the remaining part of the circle from 10, B will take 27 minutes, and therefore B will be at the starting point P again at 10:27. Just using proportionality and then finding the times. In terms of level of difficulty, I'd say moderate-ish question should not take about more than 2 minutes to solve this question. John jogs on track A at 6 kilometers per hour. Mary jogs on track B at 7.5. The total length of track and track B is 325. While John makes 9 rounds of track A, Mary makes 5 rounds of track B. In how many seconds will Mary make a round of track A? John on track A at 6 kmph. Mary on track B. Track B, Mary at 7.5 kmph. Total length of A and B is 325. Suppose the length of A and B are A and B respectively, while John makes 9 rounds. So when John makes 9 rounds, John will cover, not J, but 9 kilometer distance, 9 kilometer distance, and Mary makes 5 rounds of B. Mary will cover 5 kilometer distance. The time taken will be distance upon speed. So here it will be 9 upon 6. Here it will be 9 upon 7.5. To make kilometers meters, we can multiply 1000 on both sides. That will not change my answer. Now A and B I'm taking in distance in meters. The 1000 can get cancelled. So we can say 9A upon 6 is equal to 5B upon 7.5 divided by 1.5. 5 times should not divide by 1.5, or we can. Divide by 1.5, this becomes 5, this becomes 4, 5 and 5 cancel. And therefore, A by B comes out to 4 by 9. A by B comes out to 4 by 9. That means the length of A and B in the ratio 4 by 9. So, what will be the length of A? A will be nothing but 4 by 4 plus 9, 13 of 325. Since the sum of A and B was 325, so A will be 4 by 13 of that, B will be 9 by 13 of that. If we divide 325 by 13, 2s are 26 minus 6, 5. 5s are 65. So this comes out to 25, 25 is 100. So A is nothing but 100 meters. The question asked is, in how many seconds will Mary make round of track A? Mary has a speed of 7.5 kilometers per hour. So we can convert that speed, Mary's speed, into meters per second. 7.5 into 5 by 18 meters per second becomes the speed of Mary. The distance to be covered is 100 meters. Therefore, time taken will be distance upon speed. This answer will be in seconds. Meters upon meters per second. So this can further be written as 100 into 18 upon 7.5 into 5. 5 20s are 100 divided by 1.5. This becomes 5. This will become 12. 5 4s are 20. Therefore, 4 12s are 48 seconds becomes the answer. Again, in terms of level of difficulty, I'd say moderate-ish difficult question, not completely easy. There is chance of confusion happening, but not very difficult either. About 2 minutes, 2.5 minutes to solve the question. A cyclist leaves A at 10 a.m., reaches B at 11 a.m. Starting 10:01 a.m. every minute, a motorcycle leaves A and moves towards B. 45 such motorcycles reach B by 11 a.m. 45 such motorcycles reach B by 11 a.m. All motorcycles have the same speed. If the cyclist had doubled his speed, how many motorcycles would have reached B by the time the cyclist reached B? Now, 45. 45. At 11 o'clock, the 45th motorcycle reaches B, according to the question. The 45th motorcycle would have started at 10:45 because the first motorcycle starts at 10:01. Then the other will start at 10, second will start at 10:02, then 10:03, and so on. So the 45th motorcycle started at 10:45 from A and reached B at 11 a.m. Therefore, we can say that a motorcycle takes 15 minutes to reach A from B. B from A. Motorcycle takes 15 minutes to go from A to B. Now, the cyclist went from A to B in 1 hour, 10 to 11. If the cyclist doubles its speed, he'll reach B in half the time. If the speed is doubled, time will be half, so cyclist will reach here at 10:30. How many motorcycles would have reached here by then? Because a motorcycle takes 15 minutes, the motorcycle that reaches 10:30 would have started at 10:15. And therefore, this will be the last motorcycle to reach B. So all motorcycles which start from 10:01 to 10:15 would reach B when the cyclist doubles its speed, and therefore the answer would be 15 motorcycles. In terms of level of difficulty, I'd say a moderate level of difficulty. The time taken for this question will not be very high, but if you don't know the concept here, then it becomes a bit of a challenging question. Uh, if you've done this kind of a question before, do it in the exam. Otherwise, a call can be taken on this question. Anil and Bimal started a car journey from city C to city D, which are 72 kilometers apart. Anil took 12 hours, more than Bimal, to complete the journey. Had Anil traveled at double his actual speed, he would have taken 4 hours less. Okay. So city C to city D, Anil, Bimal, the distance is 72 kilometers. Anil took 12 hours more than Bimal. So if Bimal takes X hours, Anil takes X plus 12 hours to complete the same distance. Had Anil traveled at double his actual speed, he would have taken 4 hours less than Bimal. If Anil doubles speed, in that case, time will become half. So Anil will, in this case, take X plus 12 by 2 hours to reach D from C. According to the question, this is 4 hours less than Bimal. So we can say the new time of Anil is 4 hours less than Bimal. Bimal was X, so this is equal to X minus 4. We get an equation in X. X plus 12 is equal to 2X minus 8, which gives us X as 20. Find the respective speeds at which Anil and Bimal traveled. So X is the 20, which means X plus 12 is 32. So Anil's speed will be distance 72 by time 32 hours. Bimal's speed will be 72 distance by 20 hours. Dividing by 8. 9 8 is 72, 9 by 4 for Anil. For Bimal, dividing by 4, 18 by 5. So 9 by 4 and 18 by 5 becomes the answer, option B. This question I'd say is an easy question. Just form an equation, solve that equation, which is also not difficult, and we get the answer directly. About 90 seconds to solve the question. Ramu went by car from Calcutta to Trivandrum via Madras. Calcutta via Madras to Trivandrum without any stoppages. The average speed for the entire journey was 40 kilometers per hour. What was the average speed from Madras? We have to find out the average speed here. Overall, the average speed is 40 kmph. There are information given. The distance between Madras and Trivandrum is 0.3 times the distance between Madras and Calcutta. Okay, so if the distance from Madras and Calcutta is 10x, the distance in Madras and Trivandrum is 0.3 times. 0.3 of 10x will be 3x. 0.3 into 10 is 3. Now, if we know this, we do not know the speeds in both these intervals to get overall speed, or we do not know the split of the time. We know the distance, but to be able to find the average speed, the time distribution can differ. So that is not known from the first statement. The second statement says the average speed from Madras and Trivandrum was twice that the average speed from Calcutta and Madras. So if the average speed here was y, here it is 2y. Again, if we use only this y and 2y, depending on the distance, the time can change. And therefore, to get 40, you could have multiple answers. For example, if I say distance between Calcutta and Madras is D1, distance between Madras and Trivandrum is D2. In that case, time taken from C to M will be D1 by Y. M to T will be D2 by 2Y. And therefore, we can say that the overall speed will be distance from Calcutta to Madras plus distance from Madras to Trivandrum upon time taken from Calcutta to Madras plus time taken from Madras to Trivandrum. If suppose the average speed in these cases is A and B. Distance by speed will give us time. Distance by speed will give us the time. Second time, Calcutta to Madras, Madras to Trivandrum. Total distance upon total time will give us the average speed. So we have to have an idea of D1, D2, and A and B with respect to each other to be able to find the answer, because what we have to find is the average from Madras to Trivandrum. So basically, we have to find out D2 upon B. This is the value that we're trying to find out. Unless we know D1 with respect to D2 and A with respect to B, both of them, we'll not be able to find the answer. But if we know the information given in the question, we can say 10x plus 3x upon 10x upon A is y, the average speed, plus 3x upon 2y. This is given as 40 kilometers per hour. Find the average speed. Calcutta to Madras. Okay, so here we can write 13 upon 20. Let me set the x as well. 20x plus 3x upon 2y is equal to 40, which means 13 into 2y by 23 is equal to 40. Y is equal to 20 into 23 by 13. We get the average speed. Okay, average speed is y. We don't need the time, we just need y. So from here, we are able to get the value of y, hence the value of 2y as well. So if we use both of the statements, we'll be able to find the answer. And therefore, if the question is answered with the help of statement 1, statement 2, not. If both statement 1 and 2 are needed to answer the question, option C becomes the answer. Again, in this question, we don't have to actually calculate y. But even if we are able to understand that, finding out this ratio will need a relationship between A and B, we will realize that the question cannot be answered using either of the statements. And from there, we could have reached option C. I tried to find the value, which took a bit of time. In terms of level of difficulty, I'd say this was a easy to moderate question, because conceptually, we have to understand that to be able to find the average speed, we need a relationship of distance and time, both of them. So both the information were required. The attempt time for me was higher because I tried to find the value. Otherwise, conceptually, not a very difficult question. Two trains, T1 and T2, start from stations A and B towards each other at 50 and 30 kilometers per hour, respectively. T1, station A, T2, station B, starts towards each other 50 and 30. When they meet, it is found that the slower train traveled 24 kilometers less than the faster train. Suppose the time taken to go from A to the meeting point, say C, is T hours. We can say that the distance traveled by the first train, the speed here is 50 kilometers per hour. Here it is 30 kilometers per hour. So we can say that 50t will be the distance traveled by the first train, 30t speed into time will be the distance traveled by the second train. This difference, the difference between the distance traveled by the first and the second train is given to be 24. So we can write 50t minus 30t is equal to 24, which means 20t is equal to 24, or t is equal to 1.2 hours. 1.2 hours. What is the distance between the two stations? The distance between the two stations will be the distance traveled by each train, which is 50t plus 30t, or 80t. T is 1.2. Therefore, 18 to 1.2 or 96 kilometers becomes the answer. This was an easy question, not more than 60 seconds to solve the question. Should definitely be attempted in the exam. Ashu and Manoj start running simultaneously from the ends A and B respectively of a straight track of length 800 meters. A and B 800-meter track with speeds that are in the ratio 5:3. Ashu and Manoj. Whenever Ashu reaches either of the ends, he turns around and continues running in the same speed. Whenever Manoj meets Ashu, he turns around and continues running at the same speed. When Ashu comes back at A for the first time, how far in meters is Manoj from B? I will do this step by step. So when the first meeting happens, Ashu and Manoj, they are running in the ratio 5:3, covering a total distance of 800. Therefore, Ashu has to run 500, Manoj has to run 300. From this point onwards, Ashu will keep on running towards B. Manoj will change his direction. He will turn around and continue running with the same speed. So now Ashu is running with a speed of 5. Uh, Ashu and Manoj both are running towards B from this meeting point. This is a distance of 300. When Ashu covers this 300 meters, what is the distance that Manoj will cover? Ratio of speeds is 5:3. Ashu is covering 300. So the distance covered by Manoj will be 180. So Manoj covers 180. At this point, Ashu will turn around and start moving towards Manoj. Now the distance left here is 120. This distance will again be split in the ratio 5:3 between Ashu and Manoj. 120 split in the ratio 5:3 will be 5 by 8 of 120. This is 15. So 75 and 45. So now when they meet for the second time, they'll meet at some point. Till that point, Ashu would have covered 75 meters from B. And from this meeting point, Manoj would have covered 225 meters. At this point, Ashu will continue running towards A. Manoj will change his direction and start running towards A again. From here to reach A, Ashu has to run 800 minus 75, that is 725 meters. By the time Ashu runs from this meeting point to A and covers 725, what is the distance that Manoj will cover? 725 by Y. Suppose Manoj runs Y from the meeting point. This should be in the ratio of their speeds, which is 5:3. 725, so Y becomes 725 into 3 by 5. 5 ones are 5, 2, 5 fours are 145, 300, 420, 435. And therefore, Ashu will cover an additional distance of 435 from the meeting point. This meeting point was already 75 meters away from B. The total distance that Manoj has covered by the time Ashu reaches A from B, the distance for Manoj is 435 plus 75, which is 510 meters. Option C. For me, this would be a moderate to even difficult level of or high level of difficulty question, because I was making cases and that is the best I could think of. The attempt time would also increase, maybe 2.5 to 3 minutes. 3 athletes, Samrat, Sharath, Sridhar, run a race. Sharath finished 24 meters ahead of Sridhar and 36 ahead of Samrat. So they start the race. Sharath reaches the end point, finish 20. At this point, Sridhar is 24 meters behind Sridhar and 36 meters ahead of Samrat. Samrat is 36 meters behind Samrat. While Sridhar finished 16 meters on the same race, when Sridhar reached the end point, Sridhar was 16 meters ahead of Samrat. If each athlete runs the entire distance with their respective constant speeds, what is the length of the race? Now, if we look at this as case 1 or point 1, this is point 2 in time. This happened at some time, this happened at some time. What is the distance Sridhar runs from point 1 to point 2? Here Sridhar is 24 meters behind. Here he has reached the end point. So Sridhar is running 24 meters. What is the distance run by Samarth in the same time, or Samrat in the same time? Samrat was 36 meters behind the finish line, now only 16 meters behind. So Samrat would have run 36 minus 16, which is 20 meters. And therefore, we can say that the ratio of speed of Sridhar and Samrat is 24:20. Because in the time Sridhar runs 24, Samrat runs 20. When the race gets finished, we see that the difference between Sridhar and Samrat is 16. Here the difference is 4. If I want this difference to be 16, and the existing distance is 4. All I have to do is multiply 4 by another 4. So if we multiply both of these by 4, we get 96 is to 80. So when Sridhar runs 96 meters, Samrat will run 80 meters, and therefore a distance of 16 will be created, which is created in this race. Therefore, Sridhar is running 96 meters to finish the race, and that becomes the distance. Now, if we know how to do this, you realize that there is almost no calculation involved, and therefore I call this an easy question. Otherwise, if I am using proportionality in linear races, there might be calculation involved. For example, here we can say, if you're using proportionality, we will say that let the distance of the race be x. In the first case, Sridhar runs x minus 24, Samrat runs x minus 36. In the second case, Sridhar runs x, Samrat runs x minus 16. Solve this to get the value of x. But if we compare rather than using proportionality, the calculation becomes a lot easier, and we'll be able to do the question within maybe 1.5 minute, 90 odd seconds. You'll be able to do the question. P and Q are 2 points 100 kilometers apart. A starts running from P towards Q at 10 kilometers per hour. P and Q are points 100 kilometers apart. A starts running from P towards Q at 10 kilometers per hour. B starts running from Q at exactly the same time in the same direction. So running away from A at 20 kilometers per hour. After an hour, B turns. Okay. So suppose B reaches here, then B turns and changes speed to 10 kilometers per hour. After another hour, B turns again and changes speed to 20 kilometers per hour, and so on. Changing his speed and direction in this manner till he meets A. After how much time will A and B meet for the first time? Now, a cycle for B will get repeated in 2 hours. In 2 hours, B will cover a net distance of, in the first hour, B will go forward 20 kilometers. In the next hour, B will come back 10. Therefore, in the forward direction, B is covering 10 kilometers in 2 hours. And this cycle repeats. In 2 hours, A will cover 20 kilometers. Therefore, net if we look at, in 2 hours, the distance between A and B will reduce by 20 minus 10, because A covers 20 kilometers, B goes forward by 10. For example, when the time starts, distance between A and B is 100. After 2 hours, A has reduced this by 20, B has increased this by 10. So net, the distance will now become 90 kilometers. So after every 2 hours, the distance reduces by 10 kilometers. This becomes the relative speed. So we can write this as relative speed of AB is 10 kilometers in 2 hours. The distance that they have to cover at the starting point is A and B is 100 kilometers. So time required will be 100 kilometers being reduced at 10 kilometer per 2 hours. So this will become 20 hours. In 20 hours, A and B will meet for the first time. Basic application of relative speed. The thing is, instead of having a speed per kilometer or kilometer per hour, we are having a speed in kilometers per 2 hours, because the cycle repeats in 2 hours. Even then, I'll say moderate question, because there could be an instinct of doing this question step by step, looking at the distance between A and B after every 2 hours, and then solving, which will increase the attempt time by a bit. Therefore, moderate, about 2.5 minutes to solve the question. Anwar leaves home by car every day at 4 p.m. to pick his son from school and returns home at 6 p.m. So 4 p.m. to 6 p.m. So leaves home at 4 p.m. Therefore reaches school at 5 p.m. half the time, and therefore comes back home at 6 p.m. Going time, coming time, 1 hour each. Or one day the school was over at 4 p.m. and the son, instead of waiting for his father as usual, started walking home from school, unaware, unaware of this, starts from home as usual, meets his son on the way and returns home 15 minutes earlier than usual. If the speed of Anwar's car is 35, find the speed of his son. Now again, Anwar left at 4 p.m., but he came back 15 minutes earlier. That is 5:45. So if Anwar saves 15 minutes total, that means he would have saved 15 by 2, 7.5 minutes on each side. So here what would happen is, instead of 1 hour, he will meet his son 7.5 minutes earlier. That is 4:52.5. And therefore from here, Anwar will start to go back. So we'll reach home by 5:45. Now, this distance we can see is covered by Anwar's son. So if this distance is x, the distance x is covered by Anwar's son in 52.5 minutes. Whereas the same distance Anwar's car would have covered in only the remaining 7.5 minutes. If Anwar had to reach school, he would have taken another 7.5 minutes to cover x. But the son is taking 52.5 minutes. Because the school got over at 4, met his father at 4:52.5. So we can say that speed of the son versus speed of Amar will be inversely proportional to the time taken to cover the same distance. Time taken by Amar upon time taken by the sun. Speed of the sun, if we have to find out, speed of Anwar's car is 35. Time taken by Anwar is 7.5. Time taken by Anwar's sun is 52.5. 7 sevens are 49. So 7 divided by 7, 35, 7 5 is 35, and therefore speed of Anwar's sun is 5 kilometers per hour. Option D. Again, moderate level of difficulty. This is a question pattern that was asked in CAT once, and so you might have come across it while practicing. If that is the case, might attempt it. Otherwise, not a question that you should be doing in your first attempt. In overall, if you look at this test, as I said initially, moderate level of difficulty, 6 questions should have happened. Attempt time of 20 to 23 minutes. If I have to choose 6 questions, the ones that I would choose are 1, 4, 5, 6, 8, and 9. Which are these questions? Would definitely do this basic proportionality. Here, there could be confusion happening, so take a call on this. This also, if you've done similar questions earlier, you might be able to do it. Otherwise, take a call on this question as well. Would definitely do this question, simple equation, and then solve. Would have done this as well, because though it took time for me to solve the question, but the answer was conceptual and could have been arrived at without actually solving the entire thing. I would always do this question as well, just one basic equation and solving from there. This could be challenging because, again, I solved this question by covering every step, which can become difficult sometimes. This I thought was easy. I've done this similar questions earlier as well, so would always repeat a question that I've done in practice. This also I think was a doable sort of a question. Even if we take steps and do it, it was not very difficult because no ratio was involved per se. We just had to move B 20 kilometers ahead and then 10 kilometers back and keep repeating that process. So might take time, but conceptually easy. So would have attempted this. Again, if you've done such a question earlier, attempt it. Otherwise, you can leave this question. And therefore, my attempt would be 1, 4, 5, 6, 8, 9.